All right, Math 2, here we go. We've got the last lesson in Unit 8, Lesson 8.4.3, Circles in Context. So these are just some word problems dealing with circles. Our first one, 8-100, the Earth's orbit around the sun is slightly elliptical. That means not a perfect circle. It's kind of like a stretched out circle on one side, but can be approximated by a circle with a radius of 90 million miles. That's pretty far. How far does the Earth travel in one orbit around the sun? So if we're going with a circle here, we're just approximating this circle, the orbit around the sun would be the outside of that circle. So we're talking about circumference here. So our circumference is 2 pi times r, and in this case, r is 90 million. So 2 pi times 90 million would be 180 million times pi. So we could leave it like that as the exact answer, or we could take out our calculators, and hopefully I'll have enough zeros on my calculator for this. So if I take 180 million, what we could do is just say, okay, we got 180 million and then times it by pi, and then we could just move the decimal if we wanted to. Let me see if my calculator has enough zeros. 0, 0, 0, 0, 0, 0. All right, so there's 180 million, and then we're going to do times pi, and that comes out to, a lot, 565 million. This is approximately 565 million. We could probably just stop there, but let's give it some more. 565,486,000. And then 6, 7, and then we'll round it to an 8 at the end there. And that's in miles. So that's in 1 year. That's how far the Earth will travel around the sun. Pretty far. Approximately how fast is the Earth traveling in its orbit in space? Give your answer in miles per hour. All right, well, right now we've got miles per year. So 565. So we got 565, 486, 678. And this is miles over 1 year. Now, what we'd like to have it is in miles per hour. So to change years into days first, I would assume we would do that first. We'd have that there's 365 approximately, it's not exact, 365 days in a year. So we divide, wrong way. So it's 1 year, getting carried away with myself, over 365 days. And now the years cancel, and then my units in my denominator is in days now. And then I'd say, okay, I'm in days, I want it in hours, so I'm going to put a day on top, and then the days are going to cancel there, and I'm going to have 1 day is 24 hours, and now my denominator is in hours, my numerator is in miles, so now it's going to be in miles per hour. So basically we're just going to take the number that we had from last time, divide by 365, and divide by 24. So divided by 365 and divided by 24. So the Earth is traveling relative to the sun 64,553 miles per hour. Pretty fast. All right, so we get 65,000 approximately, or 64,000. 64,553 miles per hour. All right. Next, a certain car's windshield wiper clears a portion of the windshield in the shape of a sector as shaded in the diagram. If the wiper pivots 120 degrees during each swing, what is the area of the windshield that is wiped in each swing? Okay, so we've got a sector here, but then the wiper doesn't get this section here. So my plan is I'm going to find the area of the whole thing, so all of it, even this blank area, and then I'll subtract out the area, this blank area down here. All right, so we do 120 over 360. So we've got our central angle over 360. So this means it's a third of a circle because 120 over 360 reduces to a third. And then we're talking about area here. So this would be pi r squared. And r in this case is the full 20 right there. Then I'm going to subtract from that, because that's all of this, including this blank section. I'm going to subtract out the blank section now. So that would be 120 over 360 times pi times 5 squared. All right, like we said before, this is 1/3. So 1/3 of 20 times 20 is 400. So 1/3 of 400 pi. And then over here, we've got 1/3. 5 times 5 is 25 of 25 pi. So I've got 400 over 3 pi minus 25 over 3 pi. Now, since these are both like terms, they're both in terms of pi, I can just subtract 400 from, or 25 from 400. So I get a total of 375 over 3 pi. That's the exact answer. We would probably want to work that out and see what it actually comes out as being. Does this reduce? Wait, it does reduce. 3 goes into that. 3 goes into there 125 times. Almost missed that. So it comes out to 125 pi. So 125 pi is that area up there. So the whole area was 400 over 3 pi. The small area was 25 over 3 pi. Subtract them, you get 375 over 3 pi, which is reduced to 125 pi. So that's the exact answer. And if we wanted to approximate it, we just plug 125 pi into our calculators, 125 pi, and we get approximately 392.7. 392.7, and our units, since we're talking about area here of the sector, would be in inches squared. All right, last one. A cookie baker has an automatic mixer that turns out a sheet of dough in the shape of a square that's 12 inches wide. His cookie cutter cuts 3-inch diameter circular cookies. The supervisor complains that too much dough is being wasted and orders the baker to find out what size cookie would have the least amount of waste. All right, so they've got a 12 by 12 sheet of dough. So this is 12 inches by 12 inches. So if the cookies have a 3-inch diameter, they could fit 3 cookies on the top touching each other. So 3 inches, 3 inches, 3 inches. No, that's 4 cookies on top. What am I thinking today? I don't know. All right, so we got 4 cookies on top. And then I've got 4 cookies here. So it looks like I could fit 16 cookies in there. Because these are 3, 3, 3, 3. So that's 16, that's 12 and 12. So this makes where all the cookies are touching each other, but in between the circles, there's going to be some waste. So what I would do is I would take the squares area. So I'd take the area of the square, and then I would subtract out all of the cookies, and there's a total of 16 cookies there. And that should tell me what I'm wasting. So the square is 12 times 12, because it's a square. So 12 times 12. And then my cookies, there's 16 of them, and each of them are pi r squared, and r is not 3, that's the diameter, so r is actually 1.5. So this is 144 minus 16. And then 1.5 times 1.5 is 2.25. Brain's not working today. Is that it? Yep, it's 2.25. So this is 2.25 pi. So each cookie has an area of 2.25 pi. And if I multiply that by 16, I come up with 36. So I get an area of 144 minus 36 pi. So that's how much we're wasting. And if we wanted to find out how much exactly that is, 144 minus 36 pi ends up that we're wasting 30.9 square inches. Now use a different cookie cutter to see if you can waste less dough. Okay, so our boss is like, yeah, you're wasting way too much dough. Can you waste a little bit less? So we could either make the cookies bigger or smaller, but I think that when we're doing this, we want to make sure that the cookies are touching each other and not have any waste in between them. Let's make the cookies smaller. Let's make each cookie 1 inch. So that would mean that we have 12 cookies here and 12 cookies going this direction. I'm not actually doing 12 cookies, but you get the point. So maybe if we do that, 12 cookies by 12 cookies, we'd have 144 cookies. So our square area is 144, and then we'd have 144 cookies in there. Now each of these have a diameter of 1 inch. So when we do pi r squared, we do 0.5 squared. So the area of the cookies would be pi times r, which is 0.5 of an inch, and then squared it. So here I get 144 minus 144 cookies, and each of those cookies, 0.5 times 0.5 is 0.25, so this is 0.25 pi. 144 times 0.25 is 36. Same answer. So if we make 12 by 12 with all these cookies, we only have the same amount of waste as if we had 3-inch cookies. So 1-inch cookies and 3-inch cookies have the same amount of waste. So will every number give us the same amount of waste? Well, let's try one more. Let's say if we just did one big cookie, just got a monster cookie there. So the monster cookie would have a 6-inch diameter. So this would be 144 minus 1 cookie, that is pi times r squared, 6 squared. So this is 144, 6 squared is 36. Yep, even if I had one monster cookie, I still have the same waste of 30.9. So we should tell our boss, too bad, you're always going to have that much waste. That's the least amount of waste that we could have is 30.9 inches squared. And that proves it because we did, what if we had 1-inch diameter cookies, and here we had a 12-inch diameter cookie. And no matter what kind of cookie we made, we had the same amount of waste. Now, we could, have one big cookie and then maybe make a small cookie over there and a small cookie there. So we could, change the waste if we were willing to make different sized cookies as we did this. But with what we're given here to make all of the cookies the same, nope, we can't do it. We only have the same amount of waste each time. All right, that's all I got. Math hard. See you guys later. Bye-bye.